Today's lesson, we are going to be talking about applying the properties of rational exponents. Again, we're going to have vocabulary and properties within this lesson, and so we're going to talk about those first. The first vocabulary is the simplest form of a radical. The simplest form of a radical. When there is no perfect root, when there is no perfect root, what you do, or perfect power, perfect root or perfect power, in the radicand, and any denominator has been rationalized. Root or power. Alright, that's what simplest form of a radical means. That means you've gotten every perfect square, perfect cube, or perfect sixth power out from the radical sign. The second vocabulary is like radicals. What like radicals is when you have two radical expressions, not rational, radical expressions that have the same index and radicand. Remember that the radicand is what is underneath the radical symbol, and then the index is what's in the check mark of the radical symbol. So now we want to look at some properties. These are properties that you have seen before. We have the first property is a to the m times a to the n. You can remember this back to just the property of exponents. When it's separated by a multiplication symbol, we simply add them. A to the m plus n power. So, an example would be 4 to the 1/2 times 4 to the 3/2. Again, we want to add, so we're going to say 4 to the 1/2 plus 3/2, which is 4 to the 4/2, which can be reduced down to 4 squared, which is 16. The second property we have is a to the m n power, which means we are actually going to multiply because it is separated by parentheses. So a to the m times n. So again, an example could be 2 to the 5/2 power squared, which would be 2 to the 5/2 times 2, which is the same as saying 2 to the 5/2 times 2 over 1. So now we can see that it is 2 to the 10 over 2 power. We can reduce 10 divided by 2, so 2 to the 5th, which gives us 32. The third property is a times b to the m power is the same as saying a to the m times b to the m. So an example could be 16 times 4 to the 1/2 power. we can rewrite that as 16 to the 1/2 times 4 to the 1/2. 16 to the 1/2 is 4, and then 4 to the 1/2 is 2, so 4 times 2 gives us 8. The fourth property we have is a to the negative m power is the same as saying 1 over a to the m. So again, I have an example of 25 to the negative 1/2 is the same as saying 1 over 25 to the 1/2, which gives us 1 over 5. The fifth property is a to the m divided by a to the n. You remember that when you have the fraction, you subtract the denominator's exponent from the numerator's exponent. So we have a to the m minus n, but only when a doesn't equal 0. So my example is 3 to the 5/2 over 3 to the 1/2 equals 3 to the 5/2 minus 1/2, which gives me 3 to the 4/2, which again is 3. 4 divided by 2 is 2, which gives me 9. And then our last property for rational exponents, and I'll go ahead and put these, the rational exponents properties. The sixth one is a divided by b all to the m equals a to the m divided by b to the m, again when b does not equal 0. So this example is 27 over 8 to the 1/3. That's the same as saying 27 to the 1/3 over 8 to the 1/3, which is 3 over 2. Now, we do have two properties to talk about that are radical properties. So I'm going to do black for radical. So here are my radical properties. And the radical properties, and this is for the product, we have the nth root of a times b is equal to the nth root of a times the nth root of b. So we have an example of cubed root of 8 times 6 can be rewritten as the cube root of 8 times the cube root of 6, and the cube root of 8 is 2, so our answer would be 2 cube root of 6. And then my last one is the quotient property, and it is the nth root of a over b, which is the nth root of a over the nth root of b when b does not equal 0. So again, I have an example, and this example is the cube root of 27 over 64. So we can rewrite this as the cube root of 27 over the cube root of 64. The cube root of 27 is 3, and the cube root of 64 is 4. And so here are all the properties that you're going to have. We have talked about the vocabulary that we're going to be looking at is simplest form of a radical, which means you're getting it as low as you can go, which is what I did right here, because there is no perfect cube within 6. Like radicals, again, that is if two radical expressions have the same index and radicand. We have went through all 6 rational exponent properties and the 2 radical exponent properties, or the 2 radical properties. We have the product property and the quotient property. So from here, you'll be able to have some examples as to see what you might need to do in our future examples that we're going to talk about today. What we're going to do first is use some of the properties of exponents that we just talked about. So what we want to do is simplify. The first one I want to simplify is 8 squared times 3 squared all to the negative 1/2 power. The first thing I want to do is rewrite it, and I want to use brackets. Because 8 and 3 both have the same power inside, I can rewrite that as 8 times 3, all of that squared, and then to the negative 1/2 power. From there, I can go ahead and say, okay, well, what is 8 times 3? 8 times 3 gives us 24 squared, because again, we have our squared, all to the negative 1/2 power. Again, remember, we have, when it's separated by parentheses, you want to actually multiply. So I can say 24 times 2, to the 2 times a negative 1/2 power, which gives us 24 to the negative 1 power, which ends up being 1 over 24. So that is solving or simplifying 8 squared times 3 squared all to the negative 1/2 power. The next one we want to look at is 4 to the 1/5 power times 2 to the 1/5 power, all to the 10th power. So what I can do is I can rewrite this, because this power has to go to both of these terms inside the parentheses. So I'm going to rewrite as 4 to the 1/5 to the 10th power times 2 to the 1/5 to the 10th power. Remember, when it is separated by parentheses, you're actually going to multiply. So I can say 4 to the 1/5 times 10 times 2 to the 1/5 times 10, which gives us 4 to the 10 over 5 times 2 to the 10 over 5. And again, we know 10 divided by 5 is going to be 2, so we can say 4 squared times 2 squared. 4 squared gives us 16 times 2 squared gives us 4, which is going to give us 64. And then the third property that we want to look at is going to be one of the fractions, and it says 5 to the 3/4 over 5 to the 1/2 times 5 squared. So the first thing we want to do is we want to remember that we have to subtract the bottom exponent from the top exponent. So I'm going to go ahead and say 5 to the 3/4 minus 1/2 times 5 squared. But I can see that we don't have like terms in our denominators, so I've got to make it into a like term. So 5 to the 3/4, and to make 2 into 4, we have to multiply top and bottom by 2. So that gives us 2/4 times 5 squared, which gives us 3 minus 2 gives us 5 to the 1/4 times 5 squared. And now at this point, we are separated by a multiplication sign, and so we can say 5 to the 1/4 plus 2. Again, we need a common denominator. And so we can say we need 2 over 1, which is what a whole number 2 is, to end up having 4. So we have to multiply a top and a bottom by 4. So we can say 1/4 plus 8/4 and equals 5, 1 plus 8 to the 9/4 power. So again, these are showing you 3 different properties that we just discussed. We found that 4 to the 1/5 times 2 to the 1/5 all to the 10th power gets us 64. And we found that 5 to the 3/4 power divided by 5 to the 1/2 power, all of that times 5 squared gets us 5 to the 9/4 power. The next concept we want to look at is using properties of radicals. And again, we're going to simplify. So the first one I want to look at is the square root of 8 times the square root of 10, or 50. Let's do 50. All right, we can rewrite that as saying the square root of 8 times 50, which gives us the square root of 400. From here, we just say, well, what times itself equals 400? And it gives us 20. The second property, again, remember it was the division, the quotient. So we've got the cube root of 192 over the cube root of 24, which is equal to, we can rewrite 24 as 8 times 3. And so I'm going to go ahead and, and 192, we can rewrite as the cube root of 64 times 3. And again, the bottom is the cube root of 8 times 3. From here, we can see the cube root of 64 gives us 4, square root 3. And then the cube root of 8 gives us 2, and then, cube root of 3. And then cube root of 3 again. Because we have cube root of 3 and cube root of 3, they can cancel out, and so what it leaves us is 4 divided by 2, which is 2. And so now we have just simplified both the product property of radicals and the quotient property of radicals. Another concept we want to look at today is writing radicals in simplest form. So I went ahead and put my first one up on the board. I want to find the 5th root of 64. Again, I want in simplest form. So what we have to do is look at if there is a perfect 5th root or 5th power within 64. And there is. And so I can rewrite this by saying the 5th root of 32 times 2. And so I can now say the 5th root of 32 times the 5th root of 2. The 5th root of 32 gives us 2 times the 5th root of 2. And that is simplest form. So the second one we want to look at is the cube root of 3 over the cube root of 4. Now, the cube root of 4, because remember, we don't want radicals in the denominator. We have to rationalize that. So what we have to do is decide what can we multiply the bottom by that will make it a perfect cube. And so we can multiply it by 2. But if we multiply the bottom by 2, we have to multiply the top by 2. And so we're going to say the cube root of 3 times 2 over the cube root of 4 times 2, which I can rewrite as saying the cube root of 6 over the cube root of 8. And so now what I have left, because there's no perfect cube within 6, so I have the cube root of 6 over, but the cube root of 8 is 2. So our answer in simplest form for the cube root of 3 divided by the cube root of 4 is the cube root of 6 divided by 2. And that is how you solve and put the radicals in simplest form. Another concept we want to look at today is adding and subtracting like radicals and roots. And so again, I went ahead and put one on the board. I have the fourth root of 162 minus the fourth root of 32. What I want to do is see if I can get a fourth root out. I need a perfect fourth root. So I can rewrite this as the fourth root of 81 times the fourth root of 2 minus the fourth root of 16 times the fourth root of 2. The fourth root of 81, gives us 3 times the fourth root of 2. And then the fourth root of 16 gives us 2 times the fourth root of 2. At this point, because we have the same index and the same radicand, we can rewrite as saying 3 minus 2 times the fourth root of 2, which gives us 1 times the fourth root of 2. And that is written in simplest form. So B is 7 to the 3/2 power plus 4 times 7 to the 3/2 power. I can rewrite this because I see that this is 7 to the 3/2 and this is 7 to the 3/2. Remember that anything times 1 is itself. So I can rewrite this as 1 times 7 to the 3/2 power plus 4 times 7 to the 3/2 power. So now I see that they have a common power and a common base, and so I can multiply the outside, which is, I want to add the outside, which is 1 plus 4, and then I will times that total by the 7 to the 3/2 power. But again, all I want to do is put it into simplest form. So we don't actually have to solve it, but what I do have to do is to do 1 plus 4 gives us 5 times 7 to the 3/2 power. And this is your simplest form. That is adding and subtracting like radicals and roots. Or as you can say, when you have the index and the radicands the same. Another concept we want to look at is simplifying expressions involving variables. Remember that variables are unknown numbers that we have yet to figure out, solve for. And so in A, I have the cube root of 8 y to the 6th divided by z to the 12th. So I can go ahead and rewrite that as the cube root of 8 y to the 6th over the cube root of z to the 12th. Now when you're looking at variables, it's a little different because for every, and I should have put cube there, whatever your index number is, you have to keep in mind that for every 3 y's, you want to bring out 1. So what you're going to do is I can rewrite this as saying the cube root of 8 times the cube root of y cubed squared. And I did that backwards. I want y squared cubed. Let me rewrite that. Y squared cubed. And then again over the cube root of z to the 4th cubed. Now the reason why it helps to write it in that form is because the cube root cancels out cubed. The cube root of 8 gives us 2. And because this cube root cancels out the cube, what we have left is y squared. Again, this cube root cancels out this cubed, and so we have z to the 4th. And so this is simplifying the expression of the cube root of 8 y to the 6th divided by x to the 12th. I'm sorry, z to the 12th. And then we have b. b is the cube root of a squared over b. Now the first thing that we need to do here, because again we don't want radical signs in the denominator, so I can rewrite this as the cube root of a squared over the cube root of b. But because I only have one b in the denominator, but I need a cube root, I'm going to have to multiply the top and bottom by b squared. And so I'm going to go ahead and write that now. The cube root of a squared b squared over the cube root of b times b squared. Now that I have b cubed, because again I'll rewrite so you can see the cube root of a squared b squared over the cube root of b cubed. Again, when we have a cube root and a cube, what that means is they cancel each other out, so our answer is the cube root of a squared times b squared all over b. And that is how you simplify the cube root of a squared divided by b.